Hey Monaga 4th graders, Mr. Schroeder here with your math enrichments for the week. Today we're going to be talking about triangles and how we classify or identify them. Keep in mind that triangle, I underlined both parts of that word broken into pieces there because tri stands for three, like a tricycle has three wheels. And angles, well, we know what angles are. It's acute, a right, obtuse, straight, all those different types of angles. So anything that has three angles in it, or a polygon that has three angles in it, would be considered a triangle. And when we identify them, I like to say that we can identify them 6 different ways. And I'll show you how we do that by making a little T-chart here. On this side, I'm going to write 3 different ways that we can classify a triangle based on its side, or sides, I should say, based on its sides. On this side, we also can classify it 3 different ways based on its angles. So, every triangle can be named by its side and its angles. So for every triangle, you're going to take one word out of this list and one word out of this list to be able to identify that triangle. If we're talking about sides, there's 3 different types. We have an equilateral triangle. The word I hear in that would be, I know it's not spelled the same, but equal. Equilateral triangles have all the sides equal. And a lot of times in math, especially when you get into algebra and older grades, you're going to see them labeled with little dashes to show that they're all the same. Each one of those sides has a dash in it, just one dash. Now, all the sides are equal in an equilateral. If there's 2 equal sides in a triangle, it's called an isosceles. It's a funny looking word. It's hard to read too, but isosceles, I'll capitalize it just because we're talking about it today. Isosceles. And for me, this is just a little trick I use. Maybe you can come up with something different, but I think of the word icicle. And icicles, when I look at them hanging upside down off your roof towards this time of year, they kind of look like that, where 2 sides are equal. They both have 1 dash, but one side is different, and that has 2 dashes. So this is all equal sides. Whoops, I want to make sure that looks like an equal side. This is 2 equal sides. And it doesn't matter where they are. This could be, the triangle could be facing the other way too, and these sides are equal and this side is different. As long as 2 of the 3 are equal, it's called an isosceles triangle. So we got 1 way, 2 way, and I said there would be 3 on each side. Here's the 3rd way. We have equilateral, isosceles, and the only option that's left is if they're all equal, equilateral, 2 sides equal, we got isosceles, but if none of them are equal, it's called a scalene triangle. And here's the way I like to remember this one. On a scale, if you and 2 other friends were to step on the scale, even if it was just by a fraction, you would all be just barely maybe a little different height, or maybe just barely a little different weight. And so I like to say that we're all different on the scale. And when we talk about a scalene triangle, every last side is different. So 0 equal sides. Might look like this right one I'll draw right here. See how we have one that's short, one that's a little bit longer, and then one that is the longest. Every side is different. Equilateral, all equal. Isosceles, icicle, 2 equal sides. And scalene, we're all different on the scale. 0 equal sides. Those are the ways you can name a triangle by side. I'm moving on to this side. There's 3 ways to name it by angle. The first one of the most common ones for a 4th grade, would be a right angle. And in this case, we call it a right triangle because it has 1 right angle. So as you know, a right angle makes a perfect L. It doesn't matter where the L is at. It could be a backwards perfect L. It could be an L like that. As long as it makes a perfect 90-degree corner. And a lot of time it's labeled with this little box to show you that it's 90 degrees right on the mark. A perfect L, perpendicular line segments. Now, if you just connect those, you have a bunch of right angles. It only takes 1 right angle to be called a right triangle. Because if you think about it, there's no way you can have more than one right angle in a triangle, because as soon as you connect, here's a right angle, a perfect L. I'll connect it with another perfect L. I already have three sides and two right angles, and the tops aren't touching. It's just not a doable thing. Moving on. So a right angle has one right angle, 90 degrees. Okay, moving on from that. Well, sometimes triangles are a little bit bigger, and if the right angles, one right angle makes a right triangle, what about those angles where one of the angles is just bigger than a right angle? Well, those ones are called obtuse angles. This is probably something you've gone through in your homeroom classroom before, but anything bigger than an L is called an obtuse angle. So you can also have an obtuse triangle. And once again, that's because it has one obtuse angle. And just like that, I'll give you a few examples. Here's an obtuse angle. I'll just make a bunch of obtuse angles first. Here's an obtuse angle. That's an obtuse. Sorry, that's not the best drawing in the world. This is an obtuse because this is bigger than a right angle. This is bigger than a right angle. You cannot have two obtuse angles in one triangle. It wouldn't make sense. I'll erase this and show you. Here's an obtuse angle. No matter where I start from, I'll make an obtuse angle right here. It's not going to connect by the third side if I have two obtuse angles. So it just takes one obtuse angle to make an obtuse triangle. Finally, the last one. If it doesn't have a right and it doesn't have an obtuse angle, I'll connect that to show an obtuse triangle, then the last option is that it has all acute angles in the. So this would be called an acute triangle. And I remember that things that are acute are small. The angles that are the smallest, less than a perfect 90 degrees, are called an acute because they're so cute, they're so small. Now, like I said, in this one, you got to find all acute angles in this. All acute angles, no matter what. So every angle is less than 90. All acute angles on the interior. And when I say interior, I'm talking about the inside of the shape. This is on the interior angle of this. Here's an interior angle. Here's an interior angle. Here's an interior. Here's an interior. The ones on the inside of the triangle. So sometimes I'll give you just a few examples. Maybe I'll do it right down here. You can once again name a triangle by one name from this side and one name from this side. And every triangle has both a side's name and an angle's name. For example, I'll give you this one. We'll go like this. Okay, on this triangle, all the sides are different lengths. And I see one obtuse angle right here. These two are acute, but to be acute, it'd have to be I see one obtuse angle. So it's an obtuse triangle. And I see that all the sides are different, which means it's a scalene triangle. This is a obtuse scalene triangle. Pretty simple. I just named it from both its sides and its angles. I'll do maybe one or two more of those. Another way of doing it, let's just say we have a triangle where all the sides are equal, and every equilateral triangle, that's what this is, all the sides are equal. Sorry, I'll draw my line down. This is an equilateral triangle because all the sides are equal, and all the angles, look at them. If you're at home, try to guess. What are these types of interior angles? Do you see any perfect L's? I don't see anything bigger than an L. So it's got to be an acute. And just so you know, every equilateral, every triangle that has equal sides has to be an acute because otherwise it doesn't work. Okay, all the sides have to be the same size, and all the angles have to be the same when all the sides are the same as well. And they're actually all 60 degrees, 60 degrees, 60 degrees. Here's another little fun fact for you, if you can remember this. Every triangle's interior angles, no matter what triangle it is, they always add up to 60 plus 60 plus 60, which gives you 180. No matter what, all the interior angles on a triangle add up to 180. In case you're ever missing one and need to figure out what the other angle is. Finally, I'll do this triangle right here. Once again, looking at all the angles, acute, acute, all less than an L. So it still is an acute triangle, but this one's called an isosceles because two of the sides are the same and one is different. So make sure you keep this in mind when you look at different triangles and how you classify them by side and by angle. These are some words that you might want to memorize as you keep going on throughout fourth grade here, because they're going to be more relevant as we do some geometry later on. So thank you very much for tuning in today, guys. I hope you learned something. Talk to you later.